So your quiz covers sections 2.1 and 2.3. Your first section of your review goes over 2.1, then your second section is 2.3. So if we look at the first example there, you have x over 2 plus x over 7 is equal to 9. If you remember when we did this section, it was as long as you can find your least common denominator, you're going to multiply everything by that least common denominator to cancel out your fractions. So for example 4, you have 2 and 7 that are your denominators. Your least common denominator out of the 2 and the 7 is 14. So you're going to multiply everything by 14, which means the 14 times x over 2 is 14x over 2. The 14 times x over 7 is 14x over 7. And then you have 14 times 9. Then 9 times 4 is 36. So then 9 times 1 plus 3 is 12. So you're going to simplify. The 14 over 2 is 7x. And then the 14 over 7 is 2x is equal to 126. We add our like terms here to give us 9x is equal to 126. We divide each side by the 9. You have x is equal to, the 9 goes into 12 one time. You have 3 left over. 9 goes into 36 4 times. So x is equal to 14. For number 5, you have 5 over x minus 2 is equal to 13 over 2x minus 3. Now with this one, because it's a fraction is equal to a fraction, you can just cross multiply these in order to simplify. So you're going to do 5 times 2x minus 3 is equal to 13 times x minus 2. Distribute your 5 in. You're going to get 10x minus 15. Distribute that 13 in. That's going to give you 13x minus 26. I want to move my 10x over so that way my x's stay positive. So I'm going to subtract that from both sides. That's going to give us negative 15 is equal to 3x minus 26. We're going to add that 26 to the other side. It cancels out on the right side. You have different signs here, so you're going to keep the sign of the bigger number. So again, keep the sign of the bigger number and subtract these two. So the 6 minus 5 is 1. 2 minus 1 is 1. So it's going to be 11 is equal to 3x. Next, divide each side by the 3. And you get that x is equal to 11 over 3. Now with this one, you're going to want to check it because there is a denominator that has an x in it. As long as you can see that x is, or x cannot equal 2 and x cannot equal 3 over 2, and neither of those are your answer, you know that that x is equal to 11 over 3 is fine. For our next example, we have 14 plus 2 over x minus 1 is equal to 10. Your denominator here is the x minus 1, so you're going to multiply every term by x minus 1. Your 14 times x minus 1, you're going to distribute the 14 in. That's going to give you 14x minus 14. The 2 times x minus 1 over x minus 1, those x minus 1s are going to cancel, so you're just left with 2. And then on the other side of that equal sign, you have 10 times x minus 1, so distribute that 10 in. You're going to have 10x minus 10. From here, you can combine like terms on the left side to give yourself 14x minus 12 is equal to 10x minus 10. I want to move my 10x over, so I'm going to subtract it from both sides to give me a positive x value. So that's going to be 4x minus 12 is equal to negative 10. From here, we add the 12 over. So that's going to give us 4x is equal to 2. Divide each side by the 4, and you have that x is equal to 1/2. Again, you had a variable in the denominator from the very start. So if you want to, a different way to do this is plug in the 1/2 to that variable in the denominator, see if it gives you 0. 1/2 minus 1 is not 0, so that one is okay to have as an answer. For 11, you have 9x over 3x minus 1 minus 4 over 3x plus 1 is equal to 3. For this one, your least common denominator is the 3x minus 1 times 3x plus 1. That means that your x cannot equal negative 1/3, and it can't equal positive 1/3. So you have to make sure that if you get one of those as your answers, it's an extraneous solution. Don't include it as your final answer. We're going to multiply everything by our least common denominator. That 9x over 3x minus 1, the 3x minus 1 is part of your least common denominator, so we're going to cancel that out, and we're just going to multiply the 9x by 3x plus 1. That negative 4 over 3x plus 1 is going to multiply by just the 3x minus 1, and that 3x plus 1 is going to cancel out. The 3 is going to multiply by your least common denominator because it's not over a denominator. So it's going to multiply by the 3x minus 1 times 3x plus 1. So ultimately, we have 9x times 3x plus 1 minus 4 times 3x minus 1 is equal to 3 times 3x minus 1 times 3x plus 1. So from here, we're going to distribute and FOIL. So the 9x times 3x gives us 27x squared. 9x times 1 is 9x. The 4 times 3x is negative 12x. And the negative 4 times negative 1 is positive 4. I'm going to keep the 3 outside of the 3x minus 1 times 3x plus 1, and I'm going to FOIL that out. It is a difference of squares, so that's going to leave us with 9x squared minus 1. From here, I'm going to combine like terms on my left side and distribute that 3 in on my right side. On my left side, I have 9x minus 12x, which is going to give me a negative 3x. So it's going to be 27x squared minus 3x plus 4. On the right side, we said we're distributing at 3. So that's going to give us 27x squared minus 3. The 27x squared is going to subtract over. Oops. And that's going to leave us with negative 3x plus 4 is equal to negative 3. Because I do not have an x squared, I don't want everything on the same side. So that's why I moved that x squared over first to see if they cancel out. In this case, they do. So I'm going to move the 4 over and subtract it from both sides. That gives us negative 3x is equal to negative 7. From here, we'll divide each side by the negative 3. A negative divided by a negative is a positive, and x is going to equal positive 7 over 3. If we look from the very beginning, you had x can't equal negative 1/3, and x can't equal positive 1/3. 7 over 3 is neither of those numbers, so that's going to be our answer. For number 12, you're given 5 over x minus 5 plus 1 over x plus 5 is equal to 2 over x squared minus 25. That x squared minus 25 is x minus 5 times x plus 5. So our least common denominator from this is x minus 5 times x plus 5, which means your x cannot equal positive 5, and x cannot equal negative 5. So from here, we're going to multiply everything by our least common denominator. Your first fraction, that 5 over x minus 5, already has the x minus 5, so we're going to cancel that out, multiply the 5 up top by x plus 5. The 1 over x plus 5 already has the x plus 5 from the least common denominator, so we're just going to multiply the 1 by x minus 5. The 2 over x minus 5 times x plus 5 has both the x minus 5 and the x plus 5. So we're going to cancel it out and just multiply that 2 by 1. So ultimately, we have 5 times x plus 5 plus 1 times x minus 5 is equal to 2 times 1. On the left side, we're going to distribute the 5 and the 1, and that's going to leave us with 5x plus 25 plus x minus 5 is equal to 2. Combine your like terms on the left side. The 5x plus x is 6x. The 25 and the negative 5 is 20. So that's 6x plus 20 is equal to 2. We're going to subtract the 20 from each side. That's going to leave us with 6x is equal to negative 18. Then divide each side by the 6, and we have that x is equal to negative 3. That negative 3 is not 5 or negative 5, which is why I ended up like circling it or put a box around it for my answer. So the next part that we have, you're just performing the indicated operation. So this all comes from 2.3. For 37, we have 2 plus 13i plus 6 minus 5i. So with this one, remember, treat the I terms or your complex numbers like variable terms and just combine like terms. So we're going to get rid of the parentheses and, like I said, just combine like terms. So it's going to give us 2 plus 13i plus 6 minus 5i. The 2 plus 6, since they're like terms and they're real numbers, we're going to combine those, put them down first, so that way our answer is in a plus bi form. That's going to give us 8. Then we have 13i minus 5i, which is going to give us 8i. So that's just 8 plus 8i. And again, our answer has to be in a plus bi form, so that real part's going to come first. The imaginary part's going to go last. For 38, we have 1/2 plus the square root of 3 over 4i minus 1/2 minus the square root of 3 over 4i. You have subtraction here. Within the parentheses, you cannot do anything. So first thing you can do is distribute the parentheses, or sorry, distribute the negative. So with that, it's going to give you 1/2 plus the square root of 3 over 4i minus 1/2 plus the square root of 3 over 4i. Your 1/2s are like terms. They are opposite though, so they cancel out. You then have the square root of 3 over 4i plus the square root of 3 over 4i. To combine these, you are going to keep the I since it's addition, so keep the I, and then do what you know how to do with your fractions. Since they have the same denominator, combine the numerators, keep it over the denominator. So the square root of 3 plus the square root of 3, you have 2 of those. That's going to be 2 square root of 3 over 4i. For 39, it gives you 5i times 13 minus 8i. So we're just going to distribute this 5i in. Remember, what I times I is I squared. I squared is equal to what? -1. So that 5i times 13 is going to give us 65i. The 5i times -8i is -40i squared. You have an I squared here, so simplify that. That's going to give you 65i minus 40 times -1. If you multiply the -40 and the -1, it gives you a positive 40. So that's 65i plus 40. This is not in a plus bi form. Your real part has to go first. So we're going to rearrange our terms to be 40 plus 65i and give that as our answer. For 40, you just have a binomial times a binomial. So you're going to distribute or FOIL this out. So you have 1 plus 6i times 5 minus 2i. We're going to start with the 1 times 5, which is 5. Then the 1 times -2i is -2i. 6i times 5 is 30i. Then 6i times -2i is -12i squared. Again, we have an I squared. We also have like terms. So we're going to combine those like terms, simplify the I squared. That's going to give you 5 plus 28i minus 12 times -1. -12 times -1 is a positive 12. So this is going to be 5 plus 12, which gives us 17 plus 28i. And again, we make sure our answer is in the a plus bi form. For 45, you have 10 minus 8i times 2 minus 3i. So we are going to FOIL this out, do 10 times 2, which is 20. 10 times negative 3i is negative 30i. Negative 8i times 2 is negative 16i. And negative 8i times negative 3i is a positive 24i squared. So from here, combine your like terms, simplify the I squared. That's going to give you 20 minus 46i plus 24 times negative 1. The 24 times negative 1 makes this negative 24, so that's 20 minus 46i minus 24. 20 minus 24 is negative 4, so it's negative 4 minus 46i. For 46, you have I times 6 plus I times 3 minus 2i. If it was me, I would distribute the I first, and that would give us 6i plus I squared times 3 minus 2i. We have an I squared in that first set of parentheses, which is negative 1. So I'm just going to rewrite this as 6i minus 1 times 3 minus 2i. And then I'm going to FOIL it out. So 6i times 3 is 18i. 6i times negative 2i is negative 12i squared. Negative 1 times 3 is negative 3. And negative 1 times negative 2i is a positive 2i. From here, we're going to combine like terms if we have any and simplify that I squared. Your 18i is a like term to the 2i. That gives us 20i. That I squared is going to turn into negative 1, so that's going to be negative 12 times negative 1 minus 3. The negative 12 times negative 1 is going to make it positive 12. So 12 minus 3 is 9. That gives us 20i plus 9. That has to be written in a plus bi form, so do not give that as your answer. You're going to rearrange this to be 9 plus 20i. For 47, you have 3 plus 7i squared plus 3 minus 7i squared. So with this, because those binomials are squared, I would like you to rewrite it as 3 plus 7i times 3 plus 7i plus 3 minus 7i times 3 minus 7i. So from here, you're going to want to FOIL both of these out. So the 3 times 3 on the left is going to give you 9. 3 times 7i is 21i. 7i times 3 is 21i. And then 7i times 7i is 49i squared. This is going to be added with the 3 times 3, which is 9, minus 21i minus 21i plus 49i squared. So from here, we're just going to combine like terms. So this is going to give us 9 plus 9, or sorry, inside 9 plus 42i plus 49i squared is going to make this a negative 49i squared. So minus 49, not I squared though. The I squared makes it the negative. And then you're going to add this with the 9 minus 42i minus 49, because that I squared makes that 49 a negative. So from here, you're just going to combine like terms. You have 9 minus 49, which is negative 40, plus 42i. Again, 9 minus 49 is negative 40, minus 42i. Your I terms are opposites, so they're going to cancel each other out. Your 40, I don't know why I put that 40 with an I. Should not have an I. That negative 40 minus 40, same signs, keep the sign, add the numbers. That's just going to give you negative 80. For 48, you have 4 minus I squared minus 4 minus I squared. Or sorry, 4 plus I squared. So if we separate the 4 minus I squared to be 4 minus I times 4 minus I, it's going to give us 16. Here, well, I'll actually do it so that way you see it being done. 4 minus I times 4 minus I minus 4 plus I times 4 plus I. So again, if we FOIL it out, it's going to give us 16 minus 8I plus I squared minus 16 plus 8I plus I squared. Your I squareds here are -1. So that's 16 minus 8I minus 1 minus 16 plus 8I minus 1. Combine your like terms inside. That's going to give you 17 minus 8I minus 17. I don't know where that 17 came from. 15. 15 minus 8I minus parentheses 15 plus 8I. That negative that's in between your two parentheses is going to have to distribute. So distribute that in. That gives you 15 minus 8I minus 15 minus 8I. So like terms combine. Your 15 minus 15, they're opposites, so they cancel. Your negative 8I minus 8I is negative 16I. For our last set of examples, again from 2, 3 though, these ones you are writing the quotient in standard form. So remember, take the complex conjugate and then multiply the top and the bottom of your fractions by that complex conjugate. So with 49, you have 6 plus I over I. So remember, your complex conjugate of just I is negative I. So you'd multiply the top and the bottom by negative I. Again, the whole idea with these is to make sure you do not have an I in the denominator. So up top, put parentheses around that 6 plus I. Distribute the negative I in. It's going to give you negative 6I minus I squared. On the bottom, it's just going to be a negative I squared. Again, your I squared is equal to -1. So this is going to turn into negative 6I minus -1 over the opposite of -1. Double negatives turn to positives. This is negative 6I plus 1 all over 1. You do not need the 1 in the denominator. However, that top does need to be rewritten in A plus BI form. So that's going to give you 1 minus 6I for your answer. For number 50, you have 4 over negative 3I. The complex conjugate of your denominator here is positive 3I. So we're going to multiply the top and the bottom by positive 3I. So up top, that's going to give you 4 times 3I, which is 12I. On the bottom, the negative 3 times negative 3 is negative 9. I times I is I squared. Once again, your I squared needs to be simplified, so that's going to give you -1. So that's 12 over negative 9 times -1, which gives you 12 over positive 9, which just simplifies to give you 4 over 3. It should be 4I over 3. So this is 4I. This would be 12I. And this would be 12I. And this would be 12I. Thank you. For your next example, number 51, you have 3 plus 2I over 5 plus I. Get your complex conjugate from your denominator. I'm going to put parentheses around both my numerator and my denominator. For my denominator, I'm going to keep the 5, keep the I, but change it to subtraction. So it's going to give us 5 minus I over 5 minus I that we're multiplying the current fraction by. So we're just going to FOIL out on both the top and the bottom here. So 3 times 5 gives us 15. The 3 times negative I is negative 3I. 2I times 5 is positive 10I. And then 2I times negative I is negative 2I squared. On the bottom of that fraction, you have 5 times 5, which is 25. 5 times negative I, which is negative 5I. I times 5 is 5I. And then I times negative I is negative I squared. Simplify those I squared to be negative 1. Combine your like terms. Up top, the negative 3i plus 10i gives us 7i, so that's 15 plus 7i. The I squared turns that negative 2 into a positive 2. On the bottom, the 5i and the negative 5i are opposite, so they cancel. So you're just going to have 25 minus negative 1, which is positive 1. So we combine our like terms. That gives us 17 plus 7i all over 26. If these three terms shared a common factor, you would then simplify this fraction, but in this case they do not, so that is your answer. For number 52, same concept, but this one you have 1 minus 7i over 2 plus 3i. So I'm going to put parentheses around my numerator and my denominator. Take the complex conjugate of my denominator, which is 2 minus 3i, and multiply the top and the bottom by that 2 minus 3i. I FOIL up top. We have 1 times 2, which is 2. 1 times negative 3i is negative 3i. Negative 7i times 2 is negative 14i. Negative 7i times negative 3i is positive 21i squared. On the bottom, you're going to have 2 times 2, which is 4. 2 times negative 3i is negative 6i. 3i times 2 is positive 6i. Then 3i times negative 3i is negative 9i squared. We're going to combine like terms on the top and the bottom. We're also going to rewrite that I squared to be negative 1, or change the sign of the term that's in front of. So that's going to give us 2 minus 17i minus 21 over 4. Your 6i's cancel since they're opposite. Minus I squared minus 9i squared becomes positive 9. So this simplifies to give us negative 19 minus 17i all over 13. And again, if you could simplify, you would, but in this one you can't, so that is your answer.